Hey everybody, welcome to Math with Ace. Today we are going to be working on confidence intervals in statistics for proportions. We have already covered one sample means. We're talking about one sample for proportions now, where we are trying to estimate a parameter. Think about whenever you're in election year and you hear about polling results where maybe somebody's in favor of a certain proposition, and you have like 25% with a margin of error. That's a confidence interval. And what they're trying to do is they're taking sample data to try and generalize to what's happening in the population. It's very hard to collect data about an entire population. And so this is what we do. We sample and we generalize. Now, in the next couple of videos, we're going to talk about the conditions we should be checking. This is strictly going to be the calculation of the confidence interval and the interpretation. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who use smartphones. So we are talking about the percent of adults living in a large city. 500 randomly selected adult residents in the city are surveyed to determine whether they have smartphones. Of the 500 people surveyed, 421 said yes, they own smartphones. We are using a 95% confidence level to compute a confidence interval to estimate the true proportion of adult residents of this city who have smartphones. Now, the way a confidence interval is constructed is you have your point estimate plus or minus your margin of error. And the way that your margin of error is calculated is by taking your critical value times the standard error of the statistic. Now, the reason that we're saying it like that rather than using X bar or P hat is because this is a generic formula where you can plug in what works for the problem. This is a proportion problem, and so our point estimate should be the sample proportion. And the critical value is a z-score for proportions, where it's a t-score for means, because in means you don't know the standard deviation, and there's all the changes with the sample size. You use students' t-distribution. So this allows us to use a formula for all confidence intervals that we have. Now, in this problem, we are told that the sample size was 500, and we are also told that 421 said yes, they have smartphones. So we are trying to estimate the population proportion that have smartphones. So of the sample, 421 do, but how many, and that's 421 out of 500 to be p hat, but how many in the population do? So if I wanted to calculate p hat, I take the number of successes divided by the sample size, which is 421 over 500. Now, 421 divided by 500, I can turn that into a decimal if I would like. That's going to be 0.842. Okay, now what we're going to do is I have my point estimate. That's going to be p hat plus or minus. The critical value is going to be a z-score for alpha over 2 times the standard error of the statistic. Well, what is the standard error for proportions? I have the square root of p hat times 1 minus p hat over n. So sample successes times sample failures over the sample size. And let's fill in what we have. Well, we know that p hat is 0.842. And I also know that p hat is, again, 0.842. 1 minus 0.842, or 842 thousandths, if you want to say it correctly, over 500 is the sample size. Well, what is the z-score that goes along with this value that I'm looking for? This is a 95% confidence interval, and so I need to know what the alpha level is that goes with that so that I can calculate alpha over 2. Now, remember that alpha is the probability of committing a type 1 error. We'll get there next time. But alpha is 1 minus the confidence level. And that is 1 minus 95% as a decimal. So alpha in this case is 0.05. So then what is alpha over 2? Well, if you take 0.05 and you divide it by 2, you get 0.025. And that allows us to use technology to calculate the actual critical value that we need. Okay, now you can see that I have Stapplet here on the right. This is a standard normal distribution that we're using for our Z critical values. And I want to calculate the value corresponding to an area. So from the Stapplet homepage, I selected normal distribution. But what I want is a value. And I am looking for 0.025. And I'm using the area to the right just because it helps me in my calculations to have a positive critical value. You could do left as well, but just not take the sign. So the critical value that we have is 1.96. So Z of alpha over 2 is 1.96. And then we're going to use that to perform our calculations for our confidence interval. 0.842 plus or minus 1.96 times, so the order of operations and following in your calculator is really important. 1 minus 0.842 is 0.158, just for reference. We're going to multiply that by 0.842 and then divide that by 500. And then we're going to square root that, which gives us 0.016. Then again, I need to multiply that by 1.96 to calculate the margin of error, and that gives me 0.032. Finally, to calculate my actual interval, I do the point estimate minus the margin of error and the point estimate plus the margin of error. 0.842 minus 0.032 is 0.81, and 0.842 plus 0.032 is 0.874. So now we've calculated our confidence interval, and now we need to interpret it. So we can say we are 95% confident that the interval, and then we state the interval, 0.81 to 0.874, captures, what does it capture? The thing we're talking about. We're talking about the proportion. It's P, that's the parameter symbol, the true population proportion of adult residents of the city who have smartphones. Wait for my phone, my technology to catch up. Okay. We could also, my interpretation should come up here in a minute, but we could also use Stapplet to help us with these calculations. So let's take a pause and use Stapplet. Okay, now you can see my interpretation written. In order to perform a confidence interval in Stapplet, you need to go to a quantitative variable because remember, these are binary, you have success and failure. So I can name this. This is adults with smartphones. And I actually want to give it, I'm in quantitative, I meant for proportions, you want to select one categorical variable because this is binary, success and failure, and so you need your two categories. These are adults with smartphones. And categories, I would just call them success. You could also say has phone, doesn't have phone, failure. There were 421 successes, which meant that there were 79 failures or not phones. And we click begin analysis. Now, if you look at the image, you get the graph, and this is great, but where do I run the interval? You scroll down, you'll see perform inference. And here we are calculating the interval. And I have to tell it what level, 95% is what we want. And then here is the same interval that we calculated, 81 to 87.4. The difference is that this is a percent, and we did ours as decimals. Same exact thing, it's just a different way to represent the number. Okay, let's move on to our next value, our next problem. For a class project, a political science student at a large university wants to estimate the percentage of students who are registered voters. He surveys 500 students and found that 300 were registered voters. Calculate and interpret a 90% confidence interval for the true proportion of students who are registered voters. All right, so now, as we're doing this, a few things to think about. We have 500 students total, 300 are voters. So what is success in this situation? A success is based on the question that they tell us. They want us to interpret an interval for the true percent of students who are registered voters. That means success is registered voter, a failure is a not registered voter. So if my population, or I'm sorry, if my sample is the size of 500 and my successes, there are 300, well, how many are not registered? 300 has to add up to something to give me 500. If I subtract the two, I would find that 300 did register and 200 did not. So the sample proportion is found by taking successes out of the sample size, which I can write as a decimal of 0.6. That does mean that, as I said, failures was 200 out of 500, or 0.4. Same format as before. The point estimate of success is 0.6. Now I need to calculate the critical value, but it's a 90% critical confidence level. So if alpha equals 1 minus 0.9, then that is an alpha of 0.1. Well, then alpha over 2 is 0.1 divided by 2. And if you cut 0.1 in half, you get 0.05. So now I need a z critical value for 0.05, and I'm going to multiply that by the standard error, which is 0.6 times 1 minus 0.6, which is 0.4, and then I'm going to divide that by 500. So I'm going to go to Stapplet, and I'm going to use my normal distribution with my standard normal curve with 0 and 1, and I'm going to calculate a value to the right of 0.05. That gives me a z critical value of 1.645. And that number is always 1.645 whenever you're doing a z critical value for 90%. Then we perform the calculations. We're going to take 0.6 times 0.4, and then we're going to divide that by 500, and then we're going to square root that. And I get 0.022. If I multiply that by 1.645, I then have 0.036. I have to do, for the lower level, 0.6 minus 0.036 and a 0.6 plus 0.036. So 0.6 minus 0.036 is 0.564, and 0.6 plus 0.036 is 0.636. Let's confirm this in Stapplet. So we go back to categorical, and these are registered voters. And then you could say registered with 300 and not registered with 200. It's up to you. But then again, I scroll down to the bottom, and I'm going to perform inference where I calculate an interval. But this is a 90% interval. And it asks me, what's your success? Well, my success is registered. So my lower bound was exactly what we have on the left, 0.564 as a percent, 56.4. So how I interpret this is, we are 90% confident that the interval 0.564 to 0.636 captures what? What's the problem about? P, the true percent, It's what's highlighted right above, of students who are registered voters. Okay. Move my screen over so you can see that last part. To really perform inference on this, what you should be doing is stating out what you want to do, the parameter you want to estimate, and your confidence level. You check your conditions, and then you perform the calculations, and then you draw your conclusion. It's a 4-step process. State what you want to do, plan by checking your conditions, you do the math, and then you conclude with your statement and context. We're going to travel into hypothesis land. Thanks for watching, everyone.